Okay, good morning everyone and happy Friday. I just want to apologize ahead of time if you hear Chief and Wrigley. They are currently, well, Chief is sleeping, Wrigley's awake, but once they hear a dog, they bark. So just giving you a fair warning. Today we're going to continue off of our lesson from Wednesday. Remember that we switched the 2 days. We're going to talk about compositions of trig functions. So remember that compositions back from Algebra 2 is basically where we plug in one function into another function. Okay, and that's what we're going to be doing with our trig inverses today. So before we start, let's recall some information. We're going to keep practicing this concept that inverse sine and for inverse tangent were defined in quadrants 1 and 4. And then in inverse cosine, defined in quadrants 1 and 2. Okay, it's important to pay attention to that as we're doing these problems to worry about when x and y are positive or negative. So if we look at the very first example, we always, when working with compositions, you work from the inside out. So we're going to look at this innermost function. Okay, and pay attention to the fact that this is positive. So if inverse cosine is defined in quadrants 1 and 2, then that means we're working in quadrant 1. So both x and y are positive. Okay, and then ask yourself, where does cosine equal root 3 over 2? And that's going to be at pi over 6. Okay, you still have the sine, and then we have to take the sine of pi over 6, okay, which would be 1/2. So remember that inverse is working backwards, and then if you're not using the inverse, then you actually evaluate the function. So what is sine of pi over 6? It's 1/2. Okay. All right, let's take a look at number 2. So once again, we're going to work on the inside of the function. Okay, make note that sine is negative, and so that means we have to be in quadrant 4. So if we're in quadrant 4, x is positive, y is negative, and that means tangent would also be negative. Okay, so where does sine equal negative 1/2? Remember that it's only defined from negative pi over 2 to pi over 2. So we need to take the tangent of negative pi over 6. Okay, so remember that when we're working in inverses, we're always working in radians, but if the negative pi over 6 kind of confuses you, remember that this is the same thing as the tangent of negative 30 degrees. Okay, so that would be root 3 over 2 and negative 1/2. So when we evaluate this, the tangent of negative pi over 6 is going to be negative root 3 over 3. All right, so what I want you guys to do is try number 3 on your own, share with your partner, and then check the video. So go ahead and hit pause and try number 3. Okay, so we work from the inside out. We would get that the inverse tangent of root 3 is in quadrant 1 since it's positive, because remember that inverse tangent is only defined in quadrants 1 and 4. And then, so we get that to be pi over 3, and then we need to take the cosecant of pi over 3. So think about what does sine of pi over 3 equal, and that's root 3 over 2. So then take the reciprocal and you get 2 root 3 over 3. Okay. All right, let's go ahead and take a look at number 4. Notice on the first 3 examples that we did, everything was on the unit circle. So, and then notice from 4 through 7 that it is not on the unit circle, but we can still do these problems. And actually, how we do these problems, you could do the same thing for numbers 1 through 3. So we're going to start off the same way. Look inside the function. Okay, we see that little negative 1, so we know we're taking the inverse. And since cosine is negative, that means we're going to be working in quadrant 2. Once again, how do we know that? Because inverse cosine is only defined in quadrants 1 and 2, so if it's negative, we have to be in quadrant 2. So we don't know y yet. X is -5, r is 13. So then we just have to find what the y value is, and that's going to be a positive 12. So from then there, we're evaluating tangent, and once we evaluate, we just do the ratio of y over x, and we get -12 over 5. Okay? All right, let's go on to number 5. So looking on the inside, okay, remember that tangent's defined in, inverse tangent is defined in quadrants 1 and 4. So this means we have to be in quadrant 1. Okay, so that means everything's going to be positive. So y equals 3, x equals 4. This is a Pythagorean triple. So r equals 5. And then just find the sign. So do y over r. So that gives me 3/5. Okay, so let's go over to number 6. We're going to work on the inside of the function again. We're taking the inverse of cosine, which since it's positive, we're going to be in quadrant 1. So y is the unknown, x equals 1, r equals 4. Okay, this is not a Pythagorean triple, so we're going to have to use x squared plus y squared equals r squared to find the missing side length. So x squared plus y squared equals r squared. So we get 1 plus y squared equals 16. Y squared to equal 15. So y equals root 15. Normally you do plus or minus with square roots, but since we know we have to be in quadrant 1, we know that y has to be positive. So then from there, we just take the sign, which is going to be y over r. So that is root 15 over 4. Okay, just like before, I want you guys to try number 7 on your own. Make sure that you pay attention to what quadrant you're working in, and then also notice that you are going to be taking the reciprocal here of cosine. So go ahead, try the problem, share with your partner, and then hit pause, and then hit play when you're done. So go ahead and hit pause. Okay, so you guys should have gotten 5 over 2 root 6 for your answer. So if you look once again on the inside of the function, says that sine is going to be negative. So that means we have to be in quadrant 4 because that's where inverse of sine is defined in 1 and 4. So y has to equal -1, r has to equal 5. And then we have to go ahead and use x squared plus y squared equals r squared to find what x is going to be. And since we're in quadrant 4, x is going to be positive, so that's 2 root 6. And then since we're taking the secant, that's the reciprocal of cosine, or in other words, r over x, so 5 over 2 root 6. Okay? Just remember that when you guys are taking the inverse, you're basically representing an angle. So another way to think about this, if you want another way, is that sine of theta equals -1/2. So you are just evaluating from there, finding what the x, y, and r would be, and then taking the secant of that same exact angle. Okay? All right, last problem. I know it's not in your notes, so please go ahead and add it. So we have inverse of sine of cosine of pi over 3. So notice that in all of the other examples that we've done, if you look on the inside of the function, okay, we were taking the inverse of all of these. Okay, so every single example, we took the inverse of it, and then we evaluated the angle after finding what angle we were working with. So in number 8, notice that we are not working with the inverse. The inverse is actually on the outside. Sorry about that. So here's the inverse. Okay, so instead what we have to do is evaluate the angle first. So ask ourselves, what does cosine of pi over 3 equal? Okay, and cosine of pi over 3 equals 1/2. Okay, and then from there do the inverse. So where does sine equal 1/2? That's going to be at pi over 6. Okay, so big thing here is that anytime you are doing the inverse, you are actually finding an angle, and then when you are evaluating angle, you should be giving us a coordinate. So those x and y coordinates, either on the unit circle or using x, y, and r from x squared plus y squared equals r squared. So once again, for number 8, the inside of the function, we did not take the inverse, we just evaluated the angle being pi over 3. Cosine of pi over 3 gives me a coordinate of 1/2, and then I take the inverse, which therefore I need to provide an angle as my final answer. So inverse sine of 1/2 equals pi over 6. So that'd be a good active note to take about how when you're doing the inverse, you should be providing an angle. And then when you are evaluating an angle, you would be giving your final answer as a coordinate. Okay? All right, so you guys have the rest of the time to work on the homework, which was the composition worksheet. And then I'm assuming some of us didn't finish up yesterday's homework assignment, since I know the lesson took a good portion of the day. So do the composition worksheet. And then when you're done, please work on last night's homework, or in your group, go over problems that you guys maybe had on last night's homework. And then on Monday, there is not a video. That's just going to be work time to work on 6.2 day 2. So once again, you're just going to be working in your groups and working on those problems. Okay. I hope you all have a wonderful and safe weekend, and email me with any questions that you guys have. Thanks.